Hi everybody, today is Tuesday, November 30th, and we are in lesson 3.2 in rock transformations. Now I know you were not in class today, but I want to make sure that you guys have an opportunity to do the activities that we're doing. We're going to be in the simulation a couple times today during the lesson, and I'll show it to you on the screen, but it would really be helpful if you did it yourself in Amplify so that you can kind of, we always say that in order for you guys to learn, science is an action. It's something that you have to do. So I'm going to tell you, I'll give you some instructions. Stop the video and go ahead and try this on your own. But I will also do it on the screen for you so that I can explain what's going on, okay? All right, so this first activity is the warm-up. And we're going to actually go into the simulation, and we're going to do two things. First of all, I want you to create sedimentary and igneous rock. And then it says press move plates. And if needed, press undo at the top right corner. You can then press move plates again and make additional observations. Okay, so let me show you what I mean. If you go ahead and click on here to rock transformation simulation. Let me log in and Amplify real quick. Sorry, I should have had this done ahead of time. All right, so here we are, and we're going to do the rock transformation simulation. And it says that we had to make sedimentary rock and igneous rock. So in order to make sedimentary rock, I need to weather existing rock. Okay, so I'm going to click that. Hello, there we go. So you're going to notice the weathering here, but remember when sediment is broken down, that's weathering. But when it moves, that's erosion. Remember, weathering and erosion are two different things. So then we've got compaction and cementation. You'll notice right up here, compaction and cementation. And then I can analyze the rock, and I see that, yes, indeed, I had made sedimentary rock. All right, so now let's make igneous rock. In order to make igneous rock, I have to melt magma. So we're going to go ahead and melt, and we'll melt right down here. Now, in order to make the igneous rock, this magma has to cool and harden. It doesn't matter if I want to do it above or below the surface right now, but let's go ahead and just do at the surface. So you're going to see that this magma that's below the surface now comes to the top of the surface. It cools and hardens. And if I look at it, yes, indeed, it is igneous rock, right? This, as a matter of fact, is basalt, but it is an igneous rock. All right. Then the last thing they wanted us to do was click on this button down here on the bottom, Move Plates. So I want you to pay attention to what happens to the sedimentary rock and the igneous rock when we move the plates. And if you'll notice, we've got a convergent plate boundary. And so I've got one plate that's going below the other plate. Okay? So if you saw what happened, my sedimentary rock kind of got split. Part of it went up and part of it went down. And I'm hoping that you remember in the article that you read yesterday, we've got two new vocabulary words. We've got subduction and uplift. And so subduction, that prefix sub means below, or underneath. Subduction is when this plate goes below the other plate. And so the sedimentary rock went through subduction. And so now it's below that. But also it got split and part of it went up. And so that is called uplift. If I look really closely, I can analyze my basalt that was right there. Remember we had that little triangle of a volcano that was at the surface? That also got split. Part of it went down here. It went through the process of subduction and it's down below. And part of it went through the process of uplift and it is up above. Okay? So if we go back into our Amplify curriculum, look on that warm up, and there's a place that says what happened to the igneous and sedimentary rock formations during plate motion. Go ahead and pause the video and just in your own words explain what happened to them when we moved the plates. Okay, go ahead and make sure that you hit hand in, and we'll move on to activity number 2. Now, when we were in class, we talked pretty briefly about this article. We did something a little bit different yesterday in class, if you remember, and we talked about this second reading where we can identify exactly what's going on and how we can answer the investigation question, how can rock formations move between Earth's surface and Earth's interior? So if you remember on the back of the article, there's that paragraph that starts, it's got the heading, Plate Movement and Rock Transformations. And so we see the word uplift and we see the word subduction. And you were able to find out exactly what those mean. And so in order to answer this question, all we have to do is we can say, the rocks will either go through the process of subduction or uplift. So I'd like you to go ahead and write that answer here and then hit hand in and we can move on. Okay, so I've got 3 key concepts for you. When I talk about these, I'm going to ask you to pause and write them down in your graphic organizer. The graphic organizer is in the rock transformation file in GoodNotes. And then you're going to go to your graphic organizer. We're on key concept number 7. Key concept number 7 is plate motion moves rock formations. We saw that happen in the sim, so that's pretty easy for us to understand. Go ahead and pause, write this down, and then move on. Okay, key concept number 8 is just going to describe what subduction is. So subduction, remember that word sub means below. Subduction moves rock down below Earth's outer layer. Go ahead and pause the video and write that one down. Okay, and then last one, key concept number 9, is going to talk about uplift. So uplift moves rock upward towards Earth's surface. Go ahead and pause the video and write that one. Okay, then we've got 2 new vocabulary words. You guys have these vocab words in your flashcards, but we're using them now in our lessons. First one is uplift, and this is the process by which all the rock formations of a region are pushed up due to plate motion. So if you remember, we talked about during our unit on plate motion, we talked about at convergent plate boundaries, one plate goes below the other plate, and then the plate that's on top, it really doesn't have any place to go. It's getting stopped by that plate that's going below it. And so it forces that rock to go up. And so that is where uplift takes place. And then the second vocabulary word is subduction. And the subduction, again, is the process by which rock material moves under Earth's outer layer and into the mantle due to plate motion. So at convergent plate boundaries, we've got subduction and uplift happening all at that convergent plate boundary. Okay? All right, go ahead and go into activity number 3, moving rock formations. Now, we had that first investigation question that's in red, how do rock formations move between the surface and Earth's interior? We answered that through the process of subduction and uplift. So let's go ahead and add a new question to investigate, and that is, how do uplift and subduction lead to the transformation of rocks? So how does that happen? You guys you're going to use the sim to investigate how uplift and subduction can lead to the transformation of rocks. So we've got 2 missions, and I think it might be, I really want you to do these. Let me demonstrate it, and then you can try and recreate it on yours, okay? So the first mission, we're going to form igneous rock below Earth's surface. So the rock has to cool and harden below Earth's surface. And then we're going to use uplift or subduction to transform the rock into sedimentary rock, okay? So what that means is, let me come here. I'm going to done analyze. Let me reset. All right, so I said yes. I thought I did. Okay, so I need to create, it says create igneous rock below Earth's surface. So I'm going to go ahead and melt it because I know the only way that I can create igneous rock is if I melt existing rock. And then it wants me to cool and harden below the surface. So I'll do that right now. I'll do this one over here. Okay, so below the surface. Now, the next thing I have to do, it says, use uplift and or subduction to transform the rock into sedimentary rock. So I want to take this igneous rock, and I know it's igneous because I can look at it right here. It is igneous rock, okay? I need to somehow make that sedimentary rock. So what do? How do I make that sedimentary rock? Well, I have to turn this rock into sediment, right? So then how do I do that? Do I do that through weathering or do I do that through melting? The only way I can do it is through weathering. So we'll go ahead and weather, and I want you to keep your eye right here on this igneous rock. So we're going to weather here. And so the energy from the sun is going to cause that to break down into smaller pieces. And so there's the sediment. That sediment is going to compact and cement. So we've got sedimentary rock. But here's the thing, this is still down below. So clearly I have to do something. I have to use either uplift or subduction. How do I do that? Well, I have to move the plates. So let's go ahead and move the plate. We see now that this is going to come to the surface. Okay? So now we may even, oh, it's still working, sorry. Now let's go ahead and weather. Keep your eye right here on this thing. So we see that sediment breaking down and moving. And you'll notice that we've got weathering that takes place over hundreds of thousands of years. Compaction and cementation takes quite a long time. And I still have this igneous rock below the surface. So I may have to weather it and keep weathering it because it takes a long time. This is a process that takes a long time. But after more weathering, see now, oh, look. Ah, there it goes. So it got some of this existing rock, but this rock was pushed up to the surface through plate motion. And now some of that igneous rock was broken down into sediment and eroded, and now is down here with the sediment. So when I go back here, I formed igneous rock below Earth's surface. Then I used uplift to transform the rock into sedimentary rock. When you go into Amplify on Activity 3, it's got boxes where you can just click it and it drops down. You get to choose an answer. So go ahead and complete that answer for Activity 3. And if you want to go ahead and try it in the simulation right now, that's a great idea. You can do that. Go ahead and pause the video and we'll come back for mission 2. Okay, so for mission number 2, we are going to form sedimentary rock first and then use uplift or subduction to transform the rock into metamorphic rock. Now remember, metamorphic rock is where we take an existing rock and it goes below the surface of the earth, and it's not quite as hot, so it doesn't melt, but it gets soft. It is hot enough and there's enough pressure that it sort of gets soft, and so the rock can change just from heat and pressure. But it doesn't melt, so it doesn't go down into the mantle very far like it would for igneous rock. So let's go ahead and form sedimentary rock. I'm going to reset. And we're going to melt. We're going to form sedimentary. Oops. That's not what I want to do. Reset. Sorry. I want to form sedimentary rock, so we're going to have to do weathering again. So we see weathering is when the rock breaks down. Erosion is when the sediment moves. And that's done through wind and through water. We've got compaction and cementation. Okay, and now if I analyze that, yes, indeed, I do have sedimentary rock. Okay, so we're done analyzing. I'm supposed to take that sedimentary rock, and should I use uplift or should I use subduction to transform the rock into metamorphic rock? Well, I know metamorphic rock takes place below the surface of the earth, so I need to use subduction to bring that down. So let's go ahead and move the plate boundaries. And I do see some things going up, but we absolutely use subduction. Look right here. This is that transformation right here where it was, let's analyze the rock. It was sedimentary rock, but then right here under heat and pressure, it has changed into metamorphic rock. So when you go back into your Amplify screen on Activity 3, it's going to ask you to click on those drop boxes, and I want you to tell me what you did for that, and then go ahead and hand it in. So let's talk about how we completed mission number 1 in the sim. Again, we took the igneous rock from below. We had to bring it up to the surface. That's called uplift. And then through weathering, we were able to form sedimentary rock. And in mission number 2, we were able to transform sedimentary rock, so like this rock right here, sedimentary rock, into metamorphic rock through subduction when it came down here and was transformed into metamorphic rock. Now, I've got a question for you. In this one, we had sediment that turned into metamorphic rock. But can sediment, or sedimentary rock, be transformed into igneous rock? The answer is yes, of course it can. Any rock can be transformed into any rock. It just has to follow the steps for that rock formation. So what processes would need to occur in order for that to happen? We would have to take the sedimentary rock here, and we would have to take it way down deep into the mantle so that the rock can melt. All right? So our sim has limitations. For sedimentary rock to transform into magma and then to igneous rock, it has to be subducted really deep into the mantle. And that process is not shown in the sim model. So we do have limitations for sim, but don't let that stop you from working through what you know to be true, how the rock is formed. So just use the key concepts from PB1 and PB2 to say, okay, if I want sedimentary rock to turn into igneous rock, it has to melt. Okay, that's key concept number 5. And then it has to cool and harden either above or below the surface. That's key concept number 3. So you've got the information. You just need to kind of walk it through. Okay, that's really all we did for today. Let me know. We had a little bit of time left in class and the kids did the homework activity. You certainly can do it if you want to. There's some practice, different things you can do in the simulation. But the most important thing I want you to take away from this lesson is that any type of rock can turn into any type of rock through uplift and subduction, through weathering and melting, cementation and compaction and cementation, or cooling and hardening. You just have to go through the steps for that. All right? Okay, take care. Let me know if you've got any questions, and I hopefully talk to you soon.